Hello friends, welcome back to Java Velocity. My name is Albert Njane. I am a senior software engineer. In this video, we are going to do things practically. So it is hands-on time. Let us do this practically. Just one reminder, if you did not watch our last video, I would kindly recommend you to go and watch that video, as that is the video we are implementing those concepts practically. In the last video, we went through STK Push API, and in this video, we are going to implement every detail we discussed in that video. We are going to do it practically. Without much ado, let us get started. So in this video, we are going to use Java as our programming language. You are free to use any programming language, but I prefer Java, Spring Boot, because of the feature that Spring Boot offers for building enterprise application. Since we are building a payment system and this is an enterprise application, I just decided to choose Spring Boot. You can go ahead and use any programming language like JavaScript, Python, PHP, and so on. But for the sake of this video, we are going to use Spring Boot. So some of the technologies we are going to use in this video, we are going to use Spring Boot. We are going to use PostgreSQL. We are going to use M-Pesa integration. We are going to use Git and GitHub. So I usually recommend, before writing any Java code, it is very good to have a JDK installed on your machine. It is also very good to have an IDE. For the sake of this video, we are going to use IntelliJ IDE. You may use Eclipse, you can use VS Code, you are free to use any IDE, but I personally will use IntelliJ. Number 3, ensure you already have PostgreSQL database installed. Ensure you have PostgreSQL database installed. Remember, installation of Postgres is very easier. You just go online, you search for Postgres. Let me show you. Just go PostgreSQL download. So you click on this link. It is under postgresql.org/download. Download based on your operating system. In this case, we are using Windows. You can click Windows. For Mac OS, you click Mac. For Linux, and so on. Then you will download an installer. You choose any version that you want. I think we are using PostgreSQL 16. Then I would like you to download the installer here. So you can choose the version here, and then after downloading, go ahead and install those videos. Go ahead and install that package. I think that is it. So installation guide, just download JDK installer and run and follow the prompt instruction that will come to install it. You set the path variables, verify with Java-version if you have already installed the JDK. Remember, without the JDK, your Java program will not run, and so on. So I would like to kindly recommend you to watch my YouTube video I have a full playlist on a channel called Java Velocity. If you go to YouTube, you will see a channel called Java Velocity, where I have given some of this video, Java video, where you can watch everything. So these videos will show you how to install JDK and how to get started. So don't worry. There are quite a number of videos. There is this Master Java Beginner to Advanced. In this video, I have explained everything you need to do to get started with Java. So without further ado, let us go and do things practically. So very fast, I want to give you step by step on what we are going to do. So there is that link. As I promised you, I am not going to type everything. So I assure you, you are not going to sit down, watch me type everything. I already have the source code. I will give you the link to the GitHub repo so that you can clone the code. You can test the code, build on top of this code, improve it, add more features, just play with that code, and so on. So I am going to give you a link to this source code. So the moment you get that link, you will go to that GitHub, github.com/mpesa-integrations-v2. So you will come to this section, click on the code, copy on HTTPS, go to your local machine, clone this. How do you clone this project? It is very simple. You just write the command git clone like this. You go to your project. Maybe you create a folder. Maybe I will go to desktop, mkda, tutorial 2, then cd tutorial 2, then git clone. Paste that. It will do the cloning. Now you will have this code in your local repository. Once you have that code, open that code using your IDE. In this case, I am going to use VS Code, and inside my VS Code, I have this code, M-Pesa integration. This is the code that we have here, M-Pesa integrations. This is the code that we have here. So in this case, I want to explain everything. I want to explain this code from scratch. So I will begin by taking you through the folder structure. So this is the folder structure. We have a package called config. We have another package called controller. We have a package called DTO. Have a package called entity. We have a package called exemption. We have a package called repository. We have request. We have response. We have service. We have utils, and we also have resources folder. Under these resources, we have db.migration. We have the static templates, then applications.property. So we also have pom.xml. So if we go to pom.xml, this pom.xml contain a list of starter dependencies that we are going to use for this project. So as you can see, have a Spring Boot actuator, Spring Data JPA. So Spring Boot actuator, basically it provides production features like health check, Spring Data JPA. These provide some data abstraction. Have Spring Boot Starter validation. We have Spring Boot Starter Web. You have Flyway DB. Remember, this is for us to do the DB migration. So we want the Flyway to manage the DB migration. So it will do the migration, manage any changes to the database. Then we get the particular Flyway for a particular DB. Like for the case of PostgreSQL, this is the dependency. Then for the database, we are going to use PostgreSQL. This is the PostgreSQL driver. So of course we are going to use Rombook and so on. So that is the pom.xml. If you are generating this project from scratch, you can go to Spring, or rather type initializer. If you type Spring initializer, come here, you select Java, and here the project type we select Maven, maybe Java version 3.5 group, this group artifact, package name. Remember to select Java 17 properties or YAML. Then you add dependency here. You can add web, you can add actuator, you can add JPA, you can add Flyway migration, you can also add PostgreSQL driver, can also add validator. This is validation for doing input validation and sanitization. Then you generate your project. But since we have already done this, let us go to this project. Now the very first thing that we are going to do is to set up. So we go to applications.property. This will come with the spring.application.name. This defines the name of your application. So server.port 8080. This is the server to which our application will be running. So Tomcat will start on server port 8080. So these are database specific settings. We have data source DB URL. I will show you how we define this DB URL. Then spring.datasource.username DB username. Spring.datasource.password DB password. Remember, these are environment variables that I have stored this in a .env file. We are going to check the content of .env file. Then we have the Flyway. Spring.flyway.enabled is equals to true. Spring.flyway.baseline.onMigrate is equals to true. So these properties enables Flyway, and they tell Flyway you have been enabled to do our database migration. So you will go into the resources folder, locate db.migration, this db.migration file, execute this command to do the db migration. So other than doing the db migration, it will also handle versioning, updates, and so on. Then we have Daraja specific properties. Remember, we are integrating with the Daraja STK Push. So these are Daraja specific property. We have mpesa.daraja.consumer key, pesa consumer key. Remember, this consumer key is very, very, very important. mpesa.daraja.consumer secret, mpesa consumer secret, mpesa.daraja.passkey, mpesa passkey. I am going to show you how to get these values on the Daraja portal. mpesa.daraja.shortcode. So this is the test shortcode. Remember here, do not use the live shortcode. Use the test shortcode because we are testing in Sandbox environment. We also have mpesa.daraja.callback URL. This is the URL where you will be receiving your callback. So we are going to define this callback URL. mpesa.daraja.callback token secret mpesa callback token. I want to point out a very important fact. Number one, it is good to secure your callback URL, because some hacker may guess your callback URL and try to send millions of callbacks to that URL, and this can lead to distributed denial of service. So your callback URL should be guarded. Then we have callback security enabled true for this callback URL. We also have the database URL https sandbox.safaricom.co.ke. For the case of production, we have api.safaricom.co.ke. Then we also have the Daraja transaction type. In this case is customer pay bill online. Then we of course have logger. Remember, you should have login. It is good practice to log everything in your application, because logs are the ones that helps the technical team to know what went wrong, so that you can be able to action on the error as early as possible. So to begin with, I want to show you how to get the consumer key, consumer secret, M-Pesa passkey, shortcode. So head over to Daraja. Okay, we are in Daraja. Login. I will just log in to Daraja. So they will send an OTP to my email address 846,171. So an OTP is usually sent to an email address, but you can change this. You can change this OTP to come to your phone number by going to your profile. This is my profile, Albert Njane Kimani. I will go to my profile. Okay, I hope you are there. This is to change the OTP option to come to your phone number. I will edit profile. So you can see OTP preference is email. Choose how you want to receive the OTP code. So you can choose SMS and then validate preference, and this will start sending the OTP to your phone number if you don't want to send the OTP via the email. Now I want to go to my apps. Then I want to get specific app. Created an app some time back earlier on. Get specific app. Fetch my apps. Java. Fetch. So all apps. I can't remember the name of the app that I created, but I have so many apps. So basically what you do, you create one app here. So what I will do in this case, assume this is the app that I am going to use during my integration. Just click on that app. After clicking on that app, you will get your consumer key. Copy that consumer key, put it here, consumer key. Okay, go back, copy this consumer secret, put it here, go back. We also need the passkey, very important. Where do we get the passkey? Very, very, very important. In this case, passkey is only available to Lipa na M-Pesa production if you are testing on go live. For the case of production, this is a production application. You will get your passkey here. But now, since this is UAT, or rather this is Sandbox, I will go to APIs. I will go to APIs. Select the type of API like M-Pesa Express Simulate. Okay. After selecting M-Pesa Express Simulate, I remember I am showing you how to get the passkey. how to get the passkey. Open the simulator. After opening the simulator, it will fetch the list of apps that you have. So maybe I want to fetch my apps, this one. Then click on test credentials. So you will see your passkey here. Can you see this passkey? Copy this passkey, put it here on the passkey. Okay. For the case of shortcode, use this test shortcode, business shortcode. Copy this shortcode, put it there. Okay. What else do we need? I think we have all that we need for the sake of this tutorial. So now that I have taken you through applications.property, here is where you write your DB. Application.property basically holds the properties of our application, that is the DB properties, DB connections, M-Pesa property, flyways, login, and so on. Then after that, I want to take you through the DB migration. So once you run this application, this is the run button. Once you run this application, your Spring Boot will come and apply this migration. It will come, take this script, apply it on your database, create a table on your database, and this table will be called payment transactions, and it will have several fields. We have an ID, which is UUID. This is globally unique ID or universally unique ID. Have idempotency key. This will help us to prevent duplicate transaction. Have payment reference. We also have phone number, amount, have payment status, merchant request ID, checkout request ID, M-Pesa result code, M-Pesa result description, response code, response description, M-Pesa receipt number, transaction date, version, created at, updated at. It is good to store each and every transaction. So once you clone that code, it will come with all this. Now there are several indexes that we have. Remember, an indexing, the purpose of indexing is to increase the performance. So maybe you will be able to increase the performance without the index. Maybe, for example, I want to fetch the list of all transactions by status. Without indexing, it may take time, but index help to improve the performance of your read query. It improves the performance of your read query. So any field you are using to search data or to fetch data, it is good to index. In this case, I will use the field checkout request ID to process the callbacks. So that is why I have created an index. I will also create an index for merchant request ID, payment status to filter out the transaction, M-Pesa receipt number. Also, it is good to index based on M-Pesa receipt number because there are some scenarios where you research by M-Pesa receipt number. It's also good to fetch by to create an index created at descending, because you will write some SQL query where you want to sort by date. Also index payment status and created at. You can also combine indexes for even better performance if you want to search or fetch data on the basis of more than one field. So this is the migration file. Now I want us to go through each of these packages. We are going to start with config. Let us go to M-Pesa Daraja config. Let me stop this, close this, close. I'm closing because I want to explain everything to you from scratch. Okay, now Now we are here. So we have this M-Pesa Daraja config. I want to open this side by side with applications.property. On the application.property, there are these properties where you start with Spring Boot will automatically understand those properties. It will automatically understand them, so you don't need to bind them. But anything that does not start with this, also login, it will automatically understand the login. Anything that does not start with Spring, like mpesa.daraja, we need to define it inside our configuration. So we define at data so that you don't have to write all the boilerplate code. This is from Roblox. At configuration shows that this class will register a sequence of bins. At configuration properties, this at configuration properties helps you to prefix. So in this case, we have prefix mpesa.daraja. This is the prefix mpesa.daraja. So it will come here and say mpesa.daraja.consumer key, mpesa.daraja.consumer secret, mpesa.daraja.passkey, mpesa.daraja.shortcode, and so on. All these properties you see here. Then we have effective callback secret. Basically, who does this just a method to return the callback secret. So this configuration class is as simple as that. Now I want us to go to REST client. Remember, REST client will be used to make third-party calls to downstream services. In this case, the downstream services is M-Pesa, but we are calling M-Pesa via Daraja. So we use the REST client. So basically, REST client is equivalent to Axio or Fetch API in JavaScript. For those who are using JavaScript, REST client, this is equivalent to some sort of Axio. So we define that configuration to show that we are going to register a sequence of bins. So private final M-Pesa Daraja config, M-Pesa Daraja config. This is called dependency injection. We inject M-Pesa Daraja config because we are going to read some values from it. Then we create a constructor, public REST controller config. We pass this and we initialize this constructor. Then now we have our bin. This is our bin. So public, so we have this REST client. So basically what we are doing here is we are building the base URL and then building the REST client instance called M-Pesa REST client. So it's REST client.builder.base URL, M-Pesa Daraja config.get base URL. So you know, M-Pesa Daraja config, we have defined a property called base URL, which we saw it was sandbox.safaricom.co.ke. Then we go to build. At least we are through with our configuration. So I am going, these are just the basic setups. Without them, you cannot just go and write code to connect to Daraja, initiate STK push, do this without doing these setups. We need to do this setup. We need to do DB connection, configs, and so on. So these are the basics. From here, configs, I want to show you what we have inside our entity classes. We have an enum. So enum in Java, basically you want to store some constant, you can use enum. So this will store some payment status: pending, processing, completed, failed, timeout, cancelled. So this a transaction is pending if we don't know its status. A transaction is in processing because we have already initiated a successful STK push. As a transaction is complete because we have initiated a successful STK push and we have received the notification from M-Pesa. Therefore, that transaction is successful. A transaction is failed because number one, we have received an acknowledgement from M-Pesa and we have also received a callback or payment notification from M-Pesa. that this M-Pesa transaction has failed. Also, timeout, cancelled. A user may cancel a transaction during the time of entering the PIN and so on. Now this is the actual class. This is the actual entity class. Remember, this is we are creating a Java class called payment transaction, but then this payment transaction will be mapped by our Hibernate or JPA. It will be mapped to our database table. From these migrations, we have seen that this is payment transaction, so we will have this kind of a database table called payment transaction. All this field need to be mapped to our Java class. That is why we have this payment transaction. So we add this annotation, name is equals to payment transaction. This means that we have a table name called payment transaction, which we are going to map to this class. We have at data, at builder, at org. All these are Rombook annotation. At ID, this ID is just an annotation to tell us that this ID is a primary key and it is unique. Generated value strategy is generation type .uuid. So this means that it will not be auto incrementing, but rather it will be generating uuid type of IDs. Then we have column idempotency key, nullable false, length is 120. Nullable false means that this cannot be null. Length means that this should take 128 characters. The name idempotency key means that we are mapping this database name to this field. So you can see we have a database name called idempotency. Idempotency -key. Remember, this field should be mapped exactly as they are. Payment reference, phone number, have amount, payment status. This is an enum. This is the enum that we have defined that carries our status like cancelled, completed, processing, pending, so on, at enumerated enum type.string. This means that we want to store our enums as strings. We also have merchant request ID, checkout request ID, M-Pesa result code. I want to show you this thing. It is good to log. It is good to keep proper record. So if you go to Daraja portal, this is the request body. I want us to see the response body. We have merchant request ID, checkout request ID, response code, response description, customer message. So that is why we have checkout request ID, merchant request ID, M-Pesa result code. This will come from our acknowledgement. M-Pesa result description will come from our M-Pesa result code will come from callback. M-Pesa result description will also come from callback. We have the response code, this one from acknowledgement. Response description is from acknowledgement. So have M-Pesa receipt number. This will come from M-Pesa callback. Have transaction date. This will come from also callback. We define it as offset date time to take care of even the time zone with an offset. An offset means that if it is EAT is plus 3 hours, so it will be something like T plus 3 hours, and also maybe 2026 04 10 02 6 7 plus also this offset for the time zone and so on. Then we have the version. So version basically is used to provide duplicate, to prevent duplicate update of a database record. For example, we are processing a callback So this version will help us not to process things like callbacks twice. We also have created at creation timestamp. This means that during the record creation, a timestamp will automatically be created, and that is it will take the current time at what that record is being created into the DB. So also we have updated at update timestamp. This basically will update the DB and set updated at to this default date time at that particular time when it is being updated. So this is our payment transaction class. So I will feel free, if you are not getting or not understanding, feel free to tag me on the comment section. Then I want to go to exemption. We have exemption. So what is an exemption? An exemption is an error or unexpected things that happen that alters the normal execution of a program. So in this case, once an exemption occurs, it leads to system crashes or application crashes. And since in our case, once an exemption occurs, we don't want our application to crash. We want to handle those exemptions. That is why we have exemption handler. So this basically will handle all the M-Pesa exemption. And remember, exemption handling we usually handle at runtime, not at compile time. So in this case, we are defining error code and error message, because after handling appropriate exemption, we are going to return an error code and an error message. Like for example, this is a constructor. In this constructor, we are passing error code, error message. And in this other constructor, we are passing error code, error message, and the cause. Maybe we want to know what is the cause of that error. So this is just a method overriding. This is method overriding. Okay. Now let us go to global exemption handler. So what is global exemption handling? Basically, we don't want to override our code or just fill our code with loops of try catch blocks. In case we want to handle all our exemption globally. So that is the purpose of global exemption handling. We handle all our exemption in the same place. Remember, all these are the imports. All these are the imports. All these are the imports. We have at SL4J. This is basically for login. We are going to use SL4J for login. We have at rest controller device. Once you annotate a class with at rest controller device, this means that it is going to handle all controller exemption globally. It is going to handle all the controller exemptions globally. So at exemption handler, M-Pesa exemption dot class. Basically, this exemption handler will handle M-Pesa exemption dot class. So it will handle all the exemptions that are related to M-Pesa exemption. So let us see what it entails. So in this case, we have the first line here is to log the M-Pesa error. So basically, because we are passing M-Pesa exemption E, we are just logging M-Pesa error, then the code and the message, e.get code, e.get message. Then we are getting the customer message, get customer message, e.get error code. We are going to see this method for getting the customer message. So this is the method for getting the customer message. It is a type of string where we pass the error code. We begin by checking if the error code is null. If the error code is equals to null, that means the payment processing has failed. If error code is not null, then we go to switch case. Remember, we want to process we want to process daraja error. After processing the daraja error, convert them into human readable error, or actually the error messages are human readable, but those error code are machine code. But we want to convert them, even though they are human readable, we want to give them a good error message or good customer message. So we have case cancelled code. All this code I have defined them. You can see the cancelled code is 1032, timeout code is 1037. These are code as returned by M-Pesa gateway. We have insufficient funds code is 1, invalid request code is 2001, success code is 0, so on. So let us go back. For the case of cancelled code, return message cancelled. So the message cancelled, you cancelled the transaction. So instead of telling the customer this is that error, 1032, remember this is this result code 1032 here, this 1032. So basically instead of telling the customer request cancelled by the user, this is M-Pesa telling my business that request was cancelled by user. But then if user want to visit the see their transaction and why their transaction failed, cannot say request cancelled by user. Which user? Instead, let us give the customer you cancelled the transaction. Okay, then maybe for the case of 1037 and so on, we have this timeout, transaction timeout, please try again, and so on. So we are handling those things: timeout code, insufficient funds, invalid request, default. If none of these switch case is executed, we return the default message, which is we were unable to complete your payment, just a default message. So those are the purpose of this method. To go for a given error code, return the appropriate error message, which is customer message, which we capture it here. Then we return response entity dot status, http status.bad request. Remember, bad request, all the bad requests are 400. Dot body, what will be the body of this? The body is API response. Remember, we have a standard API response. It takes a T. T means it is just generic. We don't want to define object or string or whatever, because we want to reuse this API response, and we don't want this to break because of data type mismatch. That is why we are using generic code. So we are returning this data to the customer in the format of response code, request ID, customer message, technical message. So the customer message is what the customer sees. The technical message is what our technical team will analyze. Then we have the request ID. This is basically the trace ID that will be used to trace that log. We also have response code. We also have the data. The data is what is returned by your API. So we have a success and an error. For the sake of success, so we will call this method success, and we will pass customer message, technical message, and the data. And we will also build this response, this API response. We will build it with response code 200, request ID. This is uuid.random uuid to regenerate this request ID randomly. Then the customer message is of course what we are going to pass. The technical message is of course what we are going to pass. The data we are going to pass, and then we are going to build that response. Same for error. Have response code, customer message, technical message. Then we build response code, request ID, customer message, technical message, and we build it. So you are going to see how it is going to come. So because here we are calling dot error, remember we have seen dot error, we pass response code, customer message, technical message. So we are going to pass the response code is a dot get error code. We get the exact error code, customer message, whatever the customer message we are getting from Daraja, we convert it to our customer friendly message and we return it to the user. Then we have technical message. Basically technical message, this is the technical message as it is. Then we go to method argument. We go to this exemption handling code, method argument not valid exemption. What does this do? This does the request body validation. It does the request body validation. Whatever, maybe let me go to a correction like this China Biz M-Pesa. This China Biz here, this the login. Want to show you sample. Maybe if for the case of this, this is for the case of something like this, you have an email address, you have a password. If you put an invalid email, like that, then this method argument not valid exemption will throw an error because it will come, basically it does the validation for the request body as long as you have annotated the request with at, basically as long as in the controller you have annotated the request body. This is the request body with at valid. Anything annotated with at valid in the request body will be validated. So this handles the validation error or input error in the method body. So the error message e.get binding.get or errors.get 0.default message, it basically, remember, let me go back. Both of these two are invalid. Both the email and password are invalid. So I expect to see two errors here: invalid email, invalid password. But because we don't want to throw them at once, we first of all go step by step. Get the first error message. Okay, I am not going to throw this error before throwing the first one. So that is why we are getting the first error message. So after getting the error message, you return it. So the error code is error code 400, the error message, and this is the technical message. Then there is constraint violation exemption. What is the difference between constraint violation exemption and method argument validation exemption? So this one handles the path variables and params. For example, I may put /8. This is a path variable. I may come here and put the param status active. So basically this method argument not valid exemption is not able to validate this. It is also not able to validate path variable. For us to validate the path variable, here is where constraint violation exemption comes into play. It gets the message. So e.get constraint violation dot stream. Stream is just a pipeline to loop through, and then map constraint violation dot get message dot find first. It will get the first message. If we have like 10 parameters and they are problematic, display the message one by one, starting with the first one, or else invalid request parameter. Then of course we return response entity.status http status.bad request. This is error code 400 dot body API response dot error. We pass code 400. Error message is this message. Then failed validation message. This is just basically failed validation failed. It is good to put all your constant inside the class code app constant to make your code clean and also readable. This makes your code clean and readable. Then we also have missing request header exemption. So this checks if you have a header missing, like for example authorization header and so on. So basically this is very simple. You pass a class code missing request header exemption, then you just say http bad request API response dot error 400 and so on. So that means that whenever you make any request without the required header, your code will throw it will throw missing request header exception, and once that is thrown, our global exemption handler will handle that. This method is the one that will handle missing request header exemption. Then we also have the exemption class. Now this is the safety net. Anything that was not handled at the top here, this will now handle all the exemptions that were not handled at the top. So it is like a safety net. It handles things like internal server error, timeouts, so DB errors. So that is why we call it, we pass exemption.class. So this will handle generic exemption, those exemptions that have not been handled. First of all, it logs them, the message, then response entity dot status, internal server error, dot body API response dot error. Code is 500. Customer message is server error. We want to give customer friendly message like we were unable to process your request right now. Please try again later. Instead of telling customer like internal server error, sijui select or from this in case of DB error, then unexpected error message, but then you can see here we are logging the exact error message. Of course I have explained this to you. So that is exemption handler. We have gone through the entity, and now I want us to go through the DTO. So we have explained this API response. Now I want us to go to M-Pesa callback. This is the M-Pesa callback. This is the DTO that will map M-Pesa callback to Java class called M-Pesa callback. So this DTO called M-Pesa callback will map the callback to this Java class. Let me show you the structure of the callback. This is the structure of the callback. So you can see here, I want to explain everything step by step. Clean. This is sample, callback, unsuccessful, and this is sample, successful, callback. How do we map this type of data into a Java class? So we create a class called M-Pesa callback that will have the body, the STK callback, these levels. We start with the body, we get into a STK callbacks which contains this. Then we have callback metadata, and this callback metadata is an object that contains an array of items. So let us go back to the code. We have M-Pesa callback. We are defining at JSON property body. Remember, you are supposed to use at JSON property body. Call this field exactly as it is with the help of JSON property body. Okay. Then private body. Okay. Then we see what is there in the body. The body contains STK callback. So we go to this body. public static class body. The reason why we are defining this as static is because it belongs to this class. Therefore, we will not need to create an object to access this class called body. So at JSON property, STK callback. So this body has got STK callback. That is why we are calling STK callback at JSON property, exactly the way it is. Then private STK callback. Then we go to this STK callback. It contains merchant request ID, checkout request ID, result code, result description, and then an object of callback metadata. So we go to STK callback, has got merchant request ID, checkout request ID, result code, result description, and then an object called callback metadata. Callback metadata object. And what is the content of callback metadata? It is an array of items. So callback metadata, this callback metadata is an array of items. So in Java, we define it as a list of items. So this is a list of items. List of items. And what are these items? What are these items? And items, we have a key value pair. So we have public static item. This item contains JSON property. It contains name and it contains value. Name, value. So you see, JSON property, we have a name. Name is basically a string and a value is an object. The reason why we are defining value as an object is because we can have integer, like this is an integer, this is a string, this is a date, and so on. So we define it as an object. So that is how we construct the callback, M-Pesa callback. Now we go to payment request. Payment request. This is what we will put in our postman as the request. So under this we have at data, we have payment request, we have phone number, amount. So for you to do an STK push, you need the phone number and you also need the amount. So we have this hibernate validation. At not blank ensures that phone number is not blank. At pattern regex, validate the phone number. Pattern like this one, it must start with 254, so on. Digits, a range of 12 character, because this is 9 plus the first 3 digits, that is 12. So amount is required. At minimum value is 1 shilling, so amount must not be less than 1 shillings. Maximum value is 250,000 shillings. Amount cannot exceed 250,000 shillings. Remember, the maximum allowed transaction value for amount in M-Pesa is 250 shillings. So that is why we have put this validation. So you don't need to send a request then get the M-Pesa error. We should catch those errors early. That is the DTO. We have, of course, gone through the entity, gone through the exemption. Let us go to the repository. Basically, what is a repository? Repository means it talks with the database. It will go talk with the database, get the data, go talk with the database, get the data. So we already have the database. We annotate this with at repository. Reason being, this is a component, but at repository ensures that the database specific error are translated to Spring specific error or Hibernate error. So this is basically an interface. Payment transaction repository extends JPA repository. If you go through my video on Spring Boot, you will see I explain all this JPA repository. It gives us methods like save, find all, delete. So instead of writing custom query like selector from this, it does or for you to save, insert into those JPA method. They does the work for you, and they have been optimized for performance. So you have the first method called find by idempotence key. This method will go into the database and do selector from the payment transaction table where idempotence key is equals to this. This method will help us to prevent duplicate transaction. So have find by checkout request ID. It will go and select where checkout request ID is this. This help us to process the callback. Remember, part of the callback is checkout request ID. That is what we will be checking when processing the callback. Then we also have find by payment status. If we want to get those transactions that are completed, pending, failed, and so on, this will be paginated. That is how we have page. This will find all, and all this will find all but paginated. We have a find all that is not paginated. That is the repository. We also have response. We have M-Pesa STK push response. What is the response of an STK push? The immediate response is an acknowledgement, and this is the immediate response. Let me show you how an acknowledgement looks like. So basically, once you submit this request, you will get a response which contain merchant request ID, checkout request ID, response code, response description, customer message. All these fields, we map them into our M-Pesa STK push response. Merchant request ID, checkout request ID, response code, response description, customer message. We also have pagination response. Pagination response. Basically, this is a response we want for our transaction. It takes a list of contents. These are generic. Then we have page, of course we have page number, page size, total element, total pages, last. I'll show you all this practically when we will be doing the demo. But this one is just a way of returning our list of transaction in a paginated way. We have the response. Let us go to the utils. We have app constants. So this defines our constant like status code, messages, etc. These are very simple class. We also have structured payment logger. Remember, it is good to have some standard login. So login help you. Assume a customer is doing some transaction, then something went wrong. The customer take the screenshot of the error, then sends to your technical team or to your support team that we were unable to process this transaction. We call this error. So your support team, where will they start? First of all, they will check the logs for that particular customer. With the help of the logs, they will know what happened, because on the log you need to capture the technical message, the customer message, the response code, the request that the customer sent, and the response. Okay, so basically our logger, I want to take you through. This is a standard logger for login payment event. We have the service name, that is the name of our service, M-Pesa integrations. We have the process name. When you got that error, which process were you doing? Was it STK push? Was it callback? Was it listing of transaction? Then trace ID. This is a unique ID that identifies a transaction, or rather the unique ID that we will use to trace this log, maybe on tools like ERK, tools like ERK, those monitoring tools. We have endpoint path. It is good to log the endpoint. Which endpoint were you calling that you received an error, so that the support team can be able to know what went wrong. The duration in milliseconds. So it is good to log the time taken for that particular process to complete, because assume the log is showing that the process took 3 minutes, we can know that the performance of that endpoint is so low. This duration will help us to get some aggregations like average response time. Yeah, we also have HTTP status code, outcome message. This is the customer message, error details. If in case of an error, request payload, the data the customer sent to our API, and the response payload. So you log payment. The first thing is request JSON, sanitize JSON. We need to sanitize the JSON. That means, what do we mean by sanitize the JSON? To sanitize the JSON, we are replacing the new line character with space, and also this escape character with also a space, so that a log like this, name Robert, then we go to the new line, ID 20. So with this sanitized, if you pass this string JSON to be sanitized, it will now look something like, replace this new line with a space. We have a new line here, replace it with a space there, also this with a space there. It will come like this. Okay, let us go back. We also have the other one. You sanitize the JSON for the request and the response, then emit line. You emit line. We are going to see this method, emit line. This we log all this as a line. Okay, let's see emit line. This emit line picks all these, then it checks error detail escaped. If error detail is equals to null or error detail is blank, error details escaped will be none. Otherwise, error details dot replace this. So some of these characters need some escaping or some sort of encoding to be understood, because remember, we are logging in this format. Response code is equals to 200. We separate this response message is equals to something, blah blah blah. We separate. So remember, we are separating with this, and this need to be sanitized or encoded. Okay, then outcome escaped. If this outcome message is null, return empty. Else outcome message, this one, dot replace this and this. Then we want to log it as a line, and this is the format. Our separator is this one. The first parameter %s is timestamp. This is the service name. This is the process. This is the trace ID. This is the endpoint. This is the duration, HTTP status, and so on. If HTTP status is equals to 500, no, you know, login there, login level, we have info, we have warning, we have errors. For the case of 500 errors like 5xx, blah blah blah, log.error line. For 400 error class, log.warning. This is a warning. And else, if it does not fall into this category, then it is an info. Okay, then of course we also have summarized page. What is the purpose of this summarized page? Where is it used? Where is this used? Let me see where it is this used. Let me search. It is good to search summarized page. You see, inside log payment event paginated, we have paginated. This is for all the paginated. Remember, paginated, this means many records. Assume you are fetching like 2000 records. Will you log 2000 response? No, it will have some performance implication. Instead, we need to sanitize this error such that we need to summarize the logs. So, and how have we summarized the log? We summarize the log by just, instead of logging everything, we just put a summary, which is a map. The key is page number. The value is you return the number of page, the current page plus one. The reason why we are saying plus one is because the page in Java starts from 0. So to show 1, you have to add a 1. Then page size, you get the page size, total elements, total pages, returned, last page. So just log this page number, page size, total elements instead of displaying all those elements, so on. So that is the purpose of that class. So that is the log. Then we go to M-Pesa integration application. So this one is the entry point of our application. This is the main class. Without this, your code will not run. Okay. Yes, and it should be annotated with at Spring Boot application. At Spring Boot application, this annotation carries the auto configuration. It also carries the configuration, and it tells the Spring Boot that it will automatically do the auto configuration. Now we go to the most exciting part of the code. This is the service, and we are going to start with the payment service. Payment service. Remember, what happens is we have our payment service. Payment service. This payment service, what it will basically do is it will do the DB logic. It will then call the M-Pesa service. So this M-Pesa service is the one that will interact with Daraja. It will interact with Daraja. Okay, it will interact with Daraja. So we have payment service. It does some DB logic, then it calls the M-Pesa service, which in turn interact with Daraja, maybe to make something like STK Push and so on. So let us go to payment service. What does this service class do? It is annotated with at service to show that this is a business logic. It carries out business logic. We have at SL4J, this is for login. We have at requires arg constructor. So basically what will this do? It will inject these dependencies automatically. It will inject payment transaction repository, Daraja service, structured payment logger, because we need to log everything. This is a constructor. This is a constructor, and we don't need it since we have this. So the first thing is we get the method service name, because on the log we are logging the service name. So the first method is initiate the payment. Once this initiates the payment, what does it do? We annotate this with at transaction. Why? At transaction, these are group of action that are executed together as a unit, such that if one fails, all of them must fail, or if one succeed, all of them must succeed. And this is very critical in a payment system. Assume you are doing a banking transaction whereby you are transferring money. Transfer money from account A to account B. What will happen? What it will do now is 1, deduct money from A. B, add money to B. Okay, yes. Then deduct the money from account from A. So basically assume this succeeds, but now this fails. So you have deducted 3,000 successfully from account A, but you have not added them to account B. So where is this 3,000? Does that mean we have lost the money? Where is it? Because from account A it shows it was deducted, but for account B it was not added. Where is it? So at transaction means that if it succeed here but fails here, overall it should fail, because it should either succeed for both or fail for both. Okay, that is the meaning of at transaction. Now let us go through the code. So the first line here is for login, the duration. So this is the start time, when the execution start. This initiate payment receive has got several parameters. One of them is idempotency key, the other one is payment request, the other one is trace ID. So the first thing is to go to the DB and find if this record already exists, because we don't want to do duplicate transaction. So it will say transaction repository.find by idempotency key, and if it exists, throw for the duplicate request. Sometime you may throw, sometime you may just get that transaction. So I just decided to get it. The other one, up to this point, this means now this transaction does not exist by that idempotency key. Therefore we save this transaction into the DB. We call this payment transaction, and then we append idempotency key, payment reference, phone number, amount, payment status, and then we build this transaction, and transaction is equals to transaction repository.save transaction. We save this transaction on the DB, then you return that transaction. Remember, one thing that you need to know is the status is pending. The status is pending because we have not yet called the STK push. We are just saving the record into the database, then we make an STK push, we update the DB. After that, now is when we call M-Pesa. M-Pesa STK push response is equals to M-Pesa Daraja service. Remember I told you this payment service does some DB processing, which we have seen there, then it calls the M-Pesa Daraja service. This M-Pesa Daraja service is the one that interact with the Daraja. We pass the request, this request. We also pass the transaction reference and trace ID. Let us go to this initiate STK push inside the M-Pesa Daraja service. What does this initiate STK push does? Basically, these are the parameters we are passing. Start time. The first thing is we get the access token. After getting the access token, string access token is equals to get access token. Once we get the access token, remember I told you from the beginning that in a majority of M-Pesa endpoint, or rather all M-Pesa endpoints require an access token. So this method gets the access token. Okay, these are just for login. The first thing is the credentials. We get the consumer key and the consumer key secret. We combine them. Then we do base64 encoded to generate a base64 encoded string. So that is encoded credentials. Then we do an API call. this will return a response of type response entity string. So we say REST client dot get dot URI. We pass the authentication URL. Remember, we are passing the path because this REST client we had already built. Inside the config REST client we have already built the base URL, get base URL, this base URL, and this is the base URL here, base URL here. Okay, so that is why it will take this base URL and then it will append this get access token. It will append this dot header. We are of course passing the header, the basic encoded credentials. Remember, it is very important. We pass the authorization to basic plus encoded credentials dot receive dot to entity string dot class. So the return type will be of type string, then duration current time minus the start time. So we want to get the string row responses equals to response dot get body. If row response is null or is blank, we just log something and then we return an error that access token maybe is empty or is required. Here's JSON mapper.read row. We want to convert the JSON to a Java object. Okay, if JSON dot has access token, extract that token, extract expiry. If it has expires in, extract also this expires in, then log that we have obtained the token successfully and return the token. Remember, we are interested with the token, so you return the token. For the case of error, if it has some error, get that out error, extract the error, then the description, extract the description, error description, and then we can log them. We can log error, we can log the description, and then you throw M-Pesa exemption. If you throw the M-Pesa exemption, it will be catched by this global exemption here. Remember, we defined this global exemption. It will be catched by this M-Pesa exemption here. This is the code that will catch that M-Pesa exemption, and so on. So this is the code that generates the access token. Once we generate the access token, we come here, we build the string timestamp. Remember, on my STK push video, I told you how we generate the timestamp, and I told you it should be of format get timestamp. This is just to format the timestamp to be of format year, month, day, hour, minute, seconds. We also have to get the password. How do we generate password? We generate password by base64 encoding shortcode, passkey, and timestamp. Shortcode, passkey, timestamp. The reason why we are passing the timestamp here is because the value of the timestamp in the STK push payload should exactly be the same here. So we get the password by concatenating the shortcode, passkey, and timestamp. Then we return the base64 encoding of this. Now we go back to initiate STK push. We have already generated the password here. Now we create M-Pesa STK request. This is what we are now creating. Business, this request body, business shortcode, password, timestamp, transaction type, amount, blah blah. All this we are creating this request here. As you can see, we have business shortcode, password, timestamp, transaction type, amount, all these party A, party B, party A, party B, and so on. So we construct this After constructing this request, now we make the actual API call, and this will return a type response entity of type M-Pesa STK response. So the response will be of type M-Pesa STK push response. This one here. Remember, we constructed this response of this type, which is this one here. Okay, let us go back. So we select REST client dot post. We are calling the post method dot URI. Remember, this one is binding the base URL. Therefore, we just append M-Pesa STK push v1 process request dot header. We pass the authorization, which is bearer access token. We need to pass our access token for this request to be accepted for processing. The content type is media type dot application JSON, and then the body. What will be the body? The body is this STK request. That is what we pass in the body. Dot retrieve dot to entity. The response type is of type M-Pesa STK push request dot class. This one. So that is the response. Now we do some processing to this response. First of all, we log the duration that it has taken to make this API call. Then we return response.get body. Then we do some caching. If there are REST client exemption, we cache it there. If there is M-Pesa transaction, cache it there. But remember, this M-Pesa transaction, anything M-Pesa transaction will be handled by exemption handling. What we need to do is we log. So for the case of REST client exemption, basically what we do is we get the response body, then we log it in the format of service name as process, trace ID, endpoint, duration, status code. We log it, and then we throw it. M-Pesa error response. Once we throw it, it will be handled by our exemption handling. We catch M-Pesa exemption, we do the log, and we throw it. Once we throw it, it will be handled by our global exemption handler. The other one is the exemption, the general exemption. We have a safety net on this. So we log it and we throw it. It will be handled by M-Pesa exemption. So I think that is it for this method. So truncate for log. So truncate for log, basically this just replaces the escape characters like new line with a space, and it then validate log body maximum. We have defined this variable not to exceed 512 and 512 KB, so on. So that is what M-Pesa Daraja. We have seen that this interact with Daraja by getting the access token, initiating the STK push, and there is where we were here. Payment service, initiate STK push. After initiating the STK push, we are returning M-Pesa STK response. Then after returning that, we save this record in the DB. Remember, in our database, we will need to save merchant request ID, checkout request ID, response code, response description. So transaction.set merchant request ID, transaction.checkout request ID, response code, this, and also payment status. If the acknowledgement is 0, that means a request was received successfully for processing, or it was accepted for processing. We say payment dot processing. Now the payment is processing, else it is failed. The reason why we are saying it is processing is because a payment is processed. It will become success completed when we receive a callback. Then we log it. We log every process. Then we save it into the database. We save it in the database. but of course we catch some errors. What are some of the errors? If STK push was not successful, this STK push was not successful, we also need to save the errors into the DB. So set payment status to failed. Response description, we get the message repository.save transaction, and we log the error also. Then we throw it. Once we throw it, it will be handled by M-Pesa exemption. So that is STK push. Let us now go to process callback. Process callback is very, very important. We need to process callback after successful STK push. We need to process callback. So we process callback on the basis of checkout request ID. So we pass M-Pesa callback that we constructed. This callback contains the body, it contains the metadata, callback metadata, it contains a list of items and so on. So the first thing is to query to get the callback body. This one, sorry, this one, I want to get the callback body. This one, I want to get this information. So we say M-Pesa.call STK callback is equals to callback.getBody.get STK callback. We get this information. We are getting this information now, so that we start processing checkout request ID. We get this checkout request ID. So optional payment transaction optional is equals to transaction repository.find by checkout request ID. We find by this checkout request ID from the callback. If this transaction is empty, just M-Pesa exemption, withdraw it, so it will be handled by our exemption handler. Pass the error code, this transaction not found. Otherwise, if this is not empty, that means we have a transaction in the DB. Now we update it. Payment transaction is equals to transaction.get. Now, so we get the existing transaction in the DB. Now we update it. We set the M-Pesa result code, M-Pesa result description. Now this is the result code, result description. Then we will process this callback metadata. As if STK callback.get result code is equals to 0. You see, for result code is 0, we have callback metadata. But for result code not 0, we don't have callback metadata. So we want to get result code 0 so that we process the callback metadata. If STK callback.get callback metadata is not equals to null, STK callback.get callback metadata.get items. Now we are inside the items now. Dot for each, you see, items is an array, so we loop through this array for each item. If we have M-Pesa receipt number, this receipt number dot equals item dot get name. If this name is M-Pesa receipt number, we get this value and pass it on the M-Pesa receipt number. Transaction.set M-Pesa receipt number item.get value.toString. Do the same for transaction date. Transaction date, we get this value and save it on the database. Okay. If date is null, we just set the data as it is. We also process we transaction status dot set payment status. Now it will be completed. It will be completed. Now else, if status callback dot get result code is 1037, that is timeout. Else 1032. This now we are now handling this error, this type of error. Let me show you in a minute. This type of error, the one that we are handling right now. These errors, no, basically 1032. we are handling this error like 1032 dot get callback dot get result got 1032 say cancelled or whatever that is. Now then we save that transaction in the DB, and then after saving we log. As simple as that, we log. Now that we are done with STK push and we are done with callback processing, let us go to the last method, which is get transactions. Get transactions. So basically get transaction, this goes into the database, it queries all the transaction. After querying all the transactions, display them so that we can see those transactions. Public page, payment transaction, get transaction, payment status. We pass this payment status because we can query on the basis of status, page one based, and size. So this like page, we have the page pageable, we pass the page index, and size we sort by sort dot direction. Description, we are sorting by created at descending. Then return status. If status is not equal to null, we call this method find by payment status. We pass status and pageable. If status is null, we find all without filtering by status. So this is just that method. Then we have generate payment reference. This is just for generating a unique UUID dot to string. You generate a random payment reference. You get the first 8 character, you concatenate it with pay -8. So the total number of character will be 12. Then pass M-Pesa transaction date. This is for conversion, date conversion. Maybe sometime we may receive a date that has no timestamp. We need to pass it. And then append a timestamp to that date. So go through this code. Where you don't understand, just tell me. But basically, this pass the transaction date. Sometimes date comes as a string or numeric, so we have to convert them to offset date time. So we process them using this method. Then finally you have initiate request log. Initiate request log, because we are not logging everything. We just want to log idempotency key, phone number, amount. But remember, this phone number best practice, make sure that you mask this phone number. So that is the service class. Now let us go to the controller. We begin by self-j is for login at validated at REST controller. What is the significance of this REST controller? This tells us that this REST controller, it exposes the REST endpoint in JSON format, request mapping. So our request will be built with this form will be mapped with API v1 payment, API v1 payments. Then this is at required org constructor. This is for dependency injection. It will inject all this. Then we need to get the application name. The first endpoint is /initiate, so it will be API /v1/payment/initiate. So basically this, what it will do, it will call the payment service and then does the initiation, pass the idempotency key. We will use this key to check whether transaction is duplicate or not. Then the request and the trace ID. Where are we getting this? At request header we have idempotency key and it is required. At node blank we have message x idempotency key, header must not be empty. We have size 128 for that idempotency. This just some validation for this idempotency key. Now we have this string idempotency key. Have request body, this one. for number amount. At valid means we should do some validation so that the method argument not valid exemption will handle this. First of all, we get the trace ID. This is a unique, universal, unique ID. Then we call the payment service and initiate this. Then we return OK. API response.success payment initiated successfully. STK push dot to customer return the transaction. We also cache the M-Pesa exemption, so on. So we have also this for callback. So it will be API /v1 /payments /callback /token. So this will handle the callback. So we are passing the string token to secure the callback, and we are passing it as a path variable. That means this will be validated with constraint violation exemption. So we have path variable token request body M-Pesa callback. So it will take M-Pesa callback and does the processing. For if config.is callback security enabled and token is not empty, and token.config.get this. So if token is enabled and the token that we are passing is not equal to what we have defined on the config file, just return invalid callback token. Else, just log invalid token callback and then return forbidden. Up to this point means the token is valid and it is enabled. Therefore, we process the callback and we return OK, and we also cache. We in case of error, we cache this exemption, general exemption, and we return response entity.status http status.internal server error. Then of course this is for transactions. This one we are just calling payment method.get transaction. We pass the status, the page, and the size. So we have this request param required is false payment status. This means that status is not required. It is not mandatory. We can pass it or not. Then we have request param default value 1, admin 1. We have page number and size. Maximum size is 100, but I can say let us return a maximum of 1,000 transactions, so on. So we generate trace ID and start. These are for login purposes. We call payment service.get transaction. We pass status, page, and size, and it will be of return type payment transaction. So map string object request log is equals to new linked hash map. I think linked hash map maintains some orders. If status is not equal to null, request log.put status, request log.put page and size. So this request log will enable us to do the login. Structured logger.log payment. You see, we don't want to log everything. We just want to log the summary. Okay. Let us continue. This is for. Then we construct the response. You see this response, pagination response from the transaction dot builder dot content, transaction dot get content. So this we are constructing the response, and then we return this response here, and that is it for the repository. So in that case, we have gone through our code. So basically what you will do is this. Number one, create a file called .env. Create a file called .env. This is very, very important. If you don't do this, your code will not run. create a file called .env, then define db URLs, which is want to show you what you are supposed to define here. I want to show you what you're supposed to log here. Let me open application.property.env. So this one, this db URL is this one, db URL gdbc postgresql localhost 5432 payment db. Sure that you put this here. You also need a db username. The username of your db in my case is Postgres. The db password in my case, db password is admin. You also need M-Pesa consumer key variable, M-Pesa consumer key. You also need M-Pesa consumer secret here. You need passkey. I have it here. Short code, callback URL, callback token. So callback token, this is something you can generate. Make sure that after generating it, you also append it at the end of callback URL. Remember, this is for protecting our callbacks. So I am using this callback URL. Remember, let me go take you back to the controller. For the callback, this is API v1 payments, API v1 payment, callback, then token. That is why here I am saying API slash v1 slash payment slash callback slash token, but then I am using ngrok to forward request to my bot. So go online, download the ngrok, put it in the download folder. Okay, then go to the download folder, locate ngrok. Maybe this is ngrok. Locate the ngrok. I have already downloaded ngrok. This is the ngrok. Locate it, execute this application. Once you execute this, it will open something like this. Okay, let me restart this from scratch. Once it open ngrok like this, you say ngrok http 8080. This 8080, I want to channel my request to the port 8080. So as you can see in the application.properties, I have used port 8080. So if I enter that command, it will generate this. Copy this from here and put it in your callback URL inside the .env. Put it here. Okay, after putting it there, /API/v1/payment. Remember, we cannot use HTTP localhost because M-Pesa reject HTTP. It wants HTTPS. Now, once we are done, since our IDE does not support .env file, it will not be able to read this .env file. What you do is you come here to the M-Pesa integration application, then edit configuration, then the name of the configuration, you put M-Pesa integration. You locate this class, you locate the main class. This main class M-Pesa integrations application. Then Java, you select the version of the Java that you have. Then the main class M-Pesa integrations.main, M-Pesa-integrations.main, this one .main, and then environment variables. You see, I have located my .env. I've located my .env. So my .env will load those env files. If you don't see this option, can go here, modify option, okay, environment variables. You enable environment. If you don't enable environment variables, you will not see it. So modify it, check that environment variable so that you are able to upload them from a folder. Once you are done, you click apply, then okay. Having done that, one last thing, then we execute our code is, if you go to our env file, we have created a database. We are using a database called payment db. We are connecting to this payment db that runs on our localhost port 5432, and it is type Postgres. So I will go to pgadmin, search for pgadmin, open this pgadmin, it will open here. Just come here to the servers, select Postgres version like 16, databases, create database. I will say payment hyphen db, payment hyphen db, then I will click save. Yes, once I click on save, and then I will refresh this, you see payment db here. But because the payment db, I have a payment db, I want to now run my application. Once you run your application, basically what will happen is Flyway will execute. Once your application connects to the database, the Flyway will execute this migration and create this table in the database. So let me go to the database. You can see under schemas, tables, we have two tables, Fry schemas history and payment transaction. This is the table we are interested in. So I want to truncate this table, truncate cascade. Yes, after truncating, I want to view all the data. So you can see the data is empty, there is no record here. Now because I have run my code, I want to go to Postman correction. Go to the Postman correction, create a correction called M-Pesa integration, have an STK push, HTTP localhost 8080 API v1 payments, initiate this endpoint. We are running out of time. This video is becoming long. API v1 payments, initiate, and it is running on port 8080. That's why we are saying localhost 8080 API v1 initiate. So I want to initiate, I want to put a mobile number. Once I put that mobile number and amount, I want to send a request. So the STK push was successful. This was, so I have received an STK push. So I want to put the pin and complete this transaction. Thank you. So I have completed the transaction. So if I go to the database, you will see that this transaction has been created. Payment ref, phone number, amount. The payment status is completed because our callback has been processed. Checkout request ID, it has been processed successfully. We even have M-Pesa receipt number. If we go to our NGLog, you see our NGLog has received this callback API v1 payment callback. It has received this successfully. I will do a second transaction, but this time round, do not forget this. Remember, do not forget this. If we go to our payment controller, we have this header, request header called idempotency key. Do not forget it. Put that header here inside the headers. I have idempotency key. If I try to make a transaction using the same idempotency key, it will say payment failed, duplicate request. So our system cannot allow duplicate requests. So let me go back to the header, add a unique idempotency key, send this request, but now I will cancel. I will not put the pin. I will just cancel. You see, ngrok has received this callback. I want to go to the database, fetch this. You see this transaction has been created, but now the payment status is cancelled, and it also has the result description, request cancelled by the user. Request cancelled by the user. Now let me test the endpoint, this endpoint for getting all transactions. Localhost API everyone payment transactions. It is this endpoint here. This endpoint here, transaction, but we pass the status, the page, and the size. Page, size, status. For now, I will not pass any status. Should bring all those two transactions. You see, I have these two transactions, this one and this one. As you can see, it is taking 152 milliseconds, an average of 30 milliseconds, 34, 18. So it is very fast, and you can see it is paginated, well paginated. I want to make one last transaction, then we close the video. I will complete this. This is duplicate transaction. You cannot pay twice. This measure is very good, as it is ensures that you cannot pay twice. So look at here, I have received an STK push. I will enter my pin, send, okay, and if I get all transactions, you see there are three now, 3 transactions. So total element is 3. If I query, if I filter by cancelled, it will get just 1 transaction. If I filter by completed, just 2 transactions which I have completed successfully. So you can see that our STK push is successful. So we have done STK push, we have processed the callback, we have saved the transaction details in the DB, and we have also been able to fetch all the transactions. So best practices, this is what I want. I want you to stretch yourself. Do this. There are some things that we have not handled properly. Number 1, ensure that you cache your access token. Don't generate access token on each request. Number 2, ensure that you implement retries. Ensure that you implement retries. It is always good to implement retries, maybe whenever we have some network errors or whatever. So I think that is it for this video. See you in the next video, and in the next video we are going to talk about another API called STK M-Pesa Express Query. This queries the status of a transaction, whether it went through or not. So thank you for watching. What I would like to encourage you is to keep on going through these videos. Practice, as practice make perfect. If you have not yet subscribed to my YouTube, please subscribe to my YouTube channel. Remember to turn on the notification bell so that you may be able to get all the updates whenever I release a new video. Also, do not forget to like this video and drop a comment. About the M-Pesa integration that you have done and what are some of the challenges you have faced, and I am going to address those challenges in this series. Please drop a comment. See you in the next video.